Okay, welcome to 2.5 finally. So this is an example, or this problem is like the example I did on the board yesterday. So always, before we even start, everybody should understand that this is a given. All right, so what are we trying to do here? And what you need to figure out is how PR is equal to QS. Notice it says equals, and there's no symbols above the PR and the QS. So we are talking about the distance from P to R and Q to S. So P to R and then also Q to S. They're saying that we got to prove that those two are the exact same. So if you notice on line 2, we have PQ plus QR. We're adding two segments together, okay? And that equals RS plus QR. Okay, but notice something here. These are not just the segments. They're the same on both sides. And so what is that? That is the addition property of equality. That's what we practiced yesterday. You added something to the same, something on both sides. All right, and then the next thing it says for a reason is segment addition postulate. All right, so what two segments are being added together? Okay, and usually we take our Q from the previous line. So PQ plus QR. What does PQ plus QR equal? That equals PR. Okay, so that was the first set, and I know it was the first set because in the fourth line, that's the second side. RS plus QR equals the bigger side of QS. All right, and that's segment addition. And then we have the proof statement. PR is equal to QS. And how do we know that they're equal to each other? You have those two things right there. And they are added together to give you something the same. So look above and see if you can figure out how they are the same. So in line 2, PQ plus QR, that's where our PR is from. And we have an equal sign here. And the next part in line 2 is RS plus QR. That's this right here. That's equal to the QS. And because of the equal sign in line 2, we now can say that PR is equal to QS. And that would be substitution. We're talking about value. Is it transitive? So since we're not using substitution here, there's no numbers that are going in here, this is going to be the transitive property. And we will start to focus more on what the real reason of using the transitive property is as we progress. So that's the transitive property. And let's take a look at the answer. And there we see we have the given, the addition property of equality, the next statement, and the transitive property at the end. All right, number 3. All right. Name the property that the statement illustrates. Okay, so what are the properties? We have the segment PQ is congruent to ST, that's an if-then statement, and ST is to UV, then PQ is to UV. So here's what we have. If A is to B, and then we have B again is to something new, C. These two are the same, cross them out, we have A is to C. So that would be the transitive property. Okay, let's keep going with number 5. And we have XY is congruent to UV, then UV is congruent to XY. So they go back and forth, and remember, it's not reflexive, it's not equal or congruent to the same thing, it's congruent to something else. They just changed the order. So therefore, this is the symmetric property. And there's both of the answers, and that's what we said they were. All right, so let's go on to number 7. So here we're going to do a 2-column proof. So let's get ready here. We automatically are going to put given here. And what has been given? That angle GFH is congruent to angle GHF. Okay, so GFH inside here. That one, that angle right there, and GHF, the opposite side, this angle this way. So those two angles are congruent. That's a given. All right, so I'm going to blow this up a little bit. Okay, that's a little bit bigger. Let's go ahead and get rid of that. Now, the given part here, it says that these two angles are the same. So we need to draw these little things in here. Those two angles are the same. All right. Excuse me. Okay, so what are we trying to prove? This is the part we want to pay attention to. Supplementary means 180 degrees. So EFG, this angle right here, and angle GHF have to be supplementary. So the inside one right here. So GFE and, which is right there, and that inside one there, those are supplementary. All right, so first of all, think through this. This right here is a straight line, which means EFG and GFH, this angle in there, those are supplementary because they make a straight line. Okay, and we know that that blue angle and the single line yellow angle from the given statement, those are equal. So we could do a transitive property here and get those two to be supplementary. So let's start off here and say, since we have this little piece up here, this piece up here, the given, what does that mean to be congruent? Well, if they're congruent, these go hand in hand. Then their measurements, the measure of GFH must also be equal to the measure of angle GHF. All right, definition of congruence. All right, congruent segments, or angles, excuse me. Definition of congruent angles. All right, so whenever you have one, say the other, just in case you need them. And now we can say that angle EFG, that's the double arc line there, is congruent. I'm sorry, not congruent. It is, hello. There we go. EFG and GFH, take a look at those, are a linear pair, and that's a given in the picture. There, it's a straight line, okay? So we know that just by what it, in the picture, it's a straight line. That it's not given up above, but we can see that in the picture. It's not an assumption, it's a straight line. Okay, and then if they're a linear pair, then that means they're measurements. So, I'm sorry, that means that the angles, angle EFG and angle GFH, are supplementary. Okay, definition of linear pair. And if they're supplementary, then that means the measure of angle EFG plus the measure of angle GFH equals 180. That's the definition of supplementary. So even though you may not know why you're saying these things in this order, you just kind of go through and repeat what the next thing says. Sometimes you have to take a leap and say something, but most of the time, one thing's leading to the other. All right, so now that we have their measurements are equal to 180, and we know that GFH is equal to GHF, we can now say the measure of angle GFH, I'm sorry, back up. The measure of angle EFG plus the measure of, we're going to substitute here, okay, the GFH and the GHF. Angle GHF, because they're the same, remember, that's going to equal 180. That's substitution. We're substituting the measure. Substitution. Okay? And if the measurements are supplementary, then angle EFG and angle GHHF are supplementary. If their measurements are supplementary, then if their measurements are 180, then the angles are supplementary. That would be the definition of supplementary angles. Okay, so one step leads to the other, and a lot of times you're going from, like at the beginning here, you go from a picture being congruent to their measurements being equal, and sometimes you go the other direction. So you say that something is supplementary, then that means their measurements must add up to 180. They go hand in hand. And it's like a puzzle, you're trying to get to the proof statement, which is that right there. All right. Tough problem. And there's the answer. Sometimes you can get some things out of order. That doesn't mean it's wrong, as long as you have everything there. But it usually flows in a certain way, and it's really tough for you at the beginning, but you'll get better at it. All right, next problem. Number 13, making an argument. In the figure, SR, segment SR, so let's just highlight these things here. SR is congruent to CB. When we say they're congruent, that means the little hash mark there, those two are congruent to each other, the same size. And AC, we'll do it in blue, and QR are congruent. So that's two hash marks. Those two are congruent to each other. Your friend claims that because of this, CB is congruent to AC by the transitive property. Okay, is your friend correct? Okay, there's really no way to say that those two are congruent to each other, that CB is congruent to AC. All right, so how's come we can say that? Well, first of all, you could just draw it in a different way. All right, so we have this right here. There's that line. Okay, and that's CB, and here is AC. Obviously, those two are not the same length. All right, so there's nothing in the picture that says that they have to be the same length, and there's no transitive property proving it in any way. So the book says it a little bit better. Says that they have to have a common segment. Remember, something in common where the transitive property leaps over the common thing to the end. Okay, so there's nothing there. Number 15. Let's make this a little bit bigger to start here. All right, use the diagram and the steps below to prove that the distance from the restaurant to the movie theater, all right, so let's highlight this, restaurant to the movie theater, is the same as the distance from the cafe to the dry cleaners. All right, well, based on the hash marks there, obviously those two are the same. We have a single hash mark and a single hash mark. Those two have to be the same. And then we have two hash marks and two hash marks. Those two are the same. So if you do segment addition, you therefore can prove that those two are equal. We know they're equal. It's logical, but this is about proving what it is you're saying. So do we have enough information? We certainly do. All right, so state what is given and what is to be proven for the situation. So let's, I'm going to make this a little bit smaller, and we'll start our two-column proof. So what is given here? Okay, so we'll say RS is equal to CF. Now what's RS? That's the restaurant and the shoe store, and then the cafe and the florist. So those are equal. We also know that we have SM, which is the shoe store to the movie theater. That's equal to the florist to the dry cleaners, FD. And we also have those two things are also equal to this middle one here. That's a double hash mark, so MC there. Oops. All right, so that's a given. Those are all your givens there. Okay, so you also have to keep in mind what it is we're trying to prove here. Showing that they're the same distance. So we're trying to show that RM is equal to CD. All right, the restaurant to the movie theater is the same distance from the cafe to the dry cleaners. That's what we're trying to prove. All right, so since we have these equalities here, let's add segments together to get what we need. All right, so RS plus SM is equal to RM, gosh, RM. All right, that is segment addition property, okay? And then what's the other one? You have CF, cafe to the florist, plus the florist to the dry cleaners. That's equal to CD. All right, now we're trying to get those two things equal to each other. Well, at this point, we know that, okay, so we can show that you have this part right here, RS and CF. We're going to substitute CF in there. And also, SM and FD are equal, so we can substitute those in. So we're kind of doing two steps at once here. We can say that CF plus FD is equal to RM. If we do both of those at the same time, that's substitution. All right. Okay. Oh, and I forgot to write segment addition here. Okay. And now you have these two lines being the same, and we're talking about distance here, so we can say that CD is equal to RM, and that's by substitution as well. You just substituted one in for the other. All right, substitution. So CD is equal to the CF plus FD, so we can plug the CD into that position. And that's the answer. Let's take a look at what the book says. And there you see the book looks a lot like mine, but says all the same stuff. So depending on which way you substituted something. All right, let's move on. We are almost done. Number 17, connecting concepts. So let's see what we can do here. Write a two-column proof, then solve for x. Justify each step. Okay, let's get our two-column proof ready here. Let's put our givens in. QR is congruent to PQ, and RS is congruent to PQ. So those are your givens. Let's mark that on our example here. QR is congruent to PQ. So single hash marks, those are the same. RS is congruent to PQ. All right, so we're going to assume they're different, so RS and PQ, but we can't say that because this has a single hash mark, so those are congruent. So RS and PQ are the same. Since PQ has a single hash mark, you can use a single hash mark for RS. Prove that QR is congruent to RS. Okay, that's pretty simple here. So we're going to prove it, and then we'll solve it, okay? So based on our givens here, you do see you have two things there. And we're talking about pictures here. We're not talking about distances. So we can say that QR is congruent to RS. Why is that? You have beginning is to the middle, and the middle is to the end. So the beginning is to the end. This is the transitive property, which you proved it right off the bat. That was just a two-step equation there. And so now you can say that QR is equal to RS. That's the definition of congruence. This is probably a little bit out of order, but they go hand in hand. Remember, if their segments are congruent, then their distances are equal. And so then you can say you have these things as a given as well. That's in the picture, so you could have listed them here as a given. You can now say that 2x plus 5 is equal to the 10 minus the 3x, and then we can solve them. Add 3x, we get 5x plus 5 equals 10. Subtract the 5, and you get 5x equals 5. Divide off the 5, and x equals 1. All right, let's take a look and see what their answer is. Okay, so as we see here, they went right off the bat and showed the congruence part, and then they did the transitive property. Either way, you still get to the same position by the end, okay? So, lesson learned, I said when you have something congruent, you probably should show that they are equal, or if you have something equal, go ahead and just say that they're congruent. That way you're covered as you progress. Okay, let's go on to number 21. Solve the equation using any method and explain your choice of method. Okay, so on this one, oops, that looks like a trinomial. Let's go ahead and factor it. Can it factor at all? Well, we can't get 2 out of 3 and 7. So this tells me that we need to use the quadratic formula. All right, so these are the gray review problems. So let's refresh your memory what the quadratic formula is. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So what is a, b, and c? Just as a refresher, or maybe you didn't realize this, where the x comes from, y equals ax squared plus bx plus c. So you're looking for the coefficients on the x's and the number by itself. Those are your letters, okay? And we're solving for when y is 0. All right, so that's where this all comes from. So in this case, a is 3, b is -2, and c is -7. Those operations are attached to the coefficients there. So let's fill everything in. X equals -b, which would be +2, plus or minus b squared. -2 squared is +4, minus 4 times a times c. c is -7. All over everything, not just the radical. It's over 2 times 3. So x equals 2 plus or minus. Let's figure out what's under the radical. 4 times 3 is 12. 12 times -7 is -84. So you have 4 minus a -84. So the minus sign, and then all of this right here is just a negative. So we change, all over 6. X equals 2 plus or minus the square root of 88 all over 6. All right, so now we have to get into the simplifying mode. So we get 2 plus or minus. The square root of 88 is the same thing as 8 and 11. 8 is the same thing as 4 and 2. And the square root of 4 is 2. And since those don't break apart any further, you put them back together. So I'm teaching this because this is a skill that you must master before you leave this class. It is the most important skill of the whole year. So learn it, do it, suck it up, and get it done. So this is 2 plus or minus 2 square root of 22 all over 6. And since the 6 will reduce with both of those, we can separate this complex fraction into 2 over 6 and 2 squared root of 22 over 6. And then we can reduce. That's 1/3 plus or minus the square root of 22 over 3. And that would be your answer. And they just put the two together under or over one denominator. Okay, next problem. 23. Find the angle, measure. So this is all review, guys. You should be able to do this. Complementary means the two angles added together equal 90. So that's a 90-degree rule. So angle 1 is complementary with angle 4. So the measure of angle 1 plus the measure of angle 4 is equal to 90. You got to make sure you say M when you're saying something equals a number. M means the measurement. Okay, and then it says the measure of angle 1 is 33 degrees. So we can substitute. So this is, whenever I'm teaching you, I'm really doing a proof, just not writing it down in two-column form. So this is 33 degrees plus the measure of angle 4 equals 90. Now, how do we find the measure of angle 4? We subtract 33. Subtraction property of equality. So the measure of angle 4 is equal to 57 degrees. All right. Now, last problem. Number 27. Name the property. Well, they're the same. And when I look in the mirror, they're the same. So that's reflexive property. Congratulations, you are now done.